All right, hi weirdos. I thought I would make a little video for you about the Stroop lab and some of the math that's in the Stroop lab. If you don't need help with the math, don't watch this video. If you only need help with the ending of the lab, then skip to the ending or listen to this video at double speed so that you can get through it faster. I don't need you to hear every single word I'm saying. I'm just doing it for those of you who would like to work through it at the same pace that I'm working through it. Okay, so I'm going to use an app on my Chromebook that's called Squid. And in order for me to write better, I'm going to actually flatten my screen. I'm going to flip it over. So you're going to not see this beautiful mug anymore, and you're going to be looking at my ceiling. So my apologies about the not so beautiful view. However, I think you'll like the way it works when I write it this way better. My handwriting is a little bit better. Okay, so I copied the first row of the data table from your lab, and let's just imagine for a second that we did set A. For set A, we read the words. Whoops, sorry, I got to make sure I don't have an eraser on. I got to have my marker on. Okay, and so my partner read words. Read words. I wish I had nicer handwriting. And it was congruent because the words were either the same color as the word or the words were in black and white. And so it's not considered incongruent. So we say congruent. There was no distracting stimuli. And then let's say my partner, the first time, I already wrote all this out for myself so I could do it quickly with you. Let's say the first time my partner read their words, it took them 30 seconds and they had 0 errors. We'll calculate the score in just a moment. The second time they read it, they did a little bit faster. They did it in 25 seconds and they also had 0 errors. And the third time they just flew. They went super, super fast and did it in 18 seconds, but they did make 1 error. So now we need to calculate the SCWT scores, and that's using this this equation right here. So I want you to pay really close attention how nice and easy it is. It's 2 times the time per word, and time per word is the amount of time, like 30, for example, divided by the number of words, which was 30, times the number of uncorrected errors. And this is the part that makes it really fun. If your partner read their card and did it all perfectly, then this number is 0. And so this makes that equation really, really easy. It's just time plus 0 because it's all multiplied. I'll spell it out. I'll make that really clear. So the first time my partner had a 30 plus, and then 2, actually I should have done brackets there, 2 times the time per word was 30 seconds for 30 words, which is a 1, times the number of errors, a 0. And that's all together. This whole thing equals 0. So my first SCWT score was a 30. That means my second SWT score, also because they had 0 errors, is a 25. Thank you, partner. However, the last time my partner did make 1 mistake, I'm going to go ahead and switch the color for us so it stands out a little bit. They made 1 mistake. So let's do that trial here. So they took 18 seconds. And now we do, oops, forgot my brackets, 2 times. It took them 18 seconds to read 30 words. So it's 18 over 30. And I know that that is equal to 0.6. When I do 18 divided by 30, it's 0.6. And then times, and they made 1 error. Put that all in brackets. I guess that wasn't supposed to be a parentheses there. But anyway, so we do 2 times 0.6 is 1.2. Times 1 is still 1.2. So this whole section here is equal to 1.2. So I do 18 plus 1.2, and my answer is 19.2. And that is what goes up here, 19.2. Now, I'm going to close it a little bit. You guys all know how to do mean. So I would take 30 plus 25 plus 18. Nope, nope, and nope. Don't listen to your dumb teacher. Let me say that again. I'm circling the wrong ones. 30 for the SCWT, 25 for the SCWT, and, sorry, not 18, but 19.2. Add those 3 together. 30 plus 25 plus 19.2. And then divide the whole thing by 3 to get the mean. And when I divide it all out, I get 24.73. And that's the answer that I'm going to write right there. Okay, so I've done the first data table. Now we're going to get to the data table that's a little bit trickier. So I'm going to carry this number that's 24.73. I'm going to carry that over to this data table. I'm going to pinch it a little bit wider. 24.73. And now we're going to do a little bit trickier math, but it's really not that hard. My trial 1 score, my SCWT score, so that I'm talking about right here, was a 30. So in brackets, I'm going to do 30 minus, and now it's this score right there, minus 24.73. And I'm going to square that whole thing. And that's the answer I'm going to put in there. So when I did this already on my calculator, I got 27.78. And let me just say really quickly, for this lab activity, I want you to take everything out 2 decimals. You are about to learn how to do what's called significant figures in just like the next day, but you aren't really mastering that quite yet, so we're not going to worry about significant figures yet. So I want you to take everything out to 2 decimals. Okay, so 27.78, I'm going to write right there, 27.78. How about I switch colors just to help our eyeballs? So now we'll try the next one. For letter B, trial 2 score was 25 minus 24.73, and then I square it. And so my answer for that one is 0.073. And then you can check your work as I'm doing this. You can double check your work against mine to see if you're doing the math correctly. And then the third trial score was 19.2. That's my corrected SCWT score. Minus the mean was 24.73. Notice that 19 minus 24.73 is a negative, but when you square it, it becomes a positive. So squared, it becomes 30.58. So I write that here, 30.58. Now, column D, you add all 3 together. You add A plus B plus C. So I'm going to do 27.8. I'm going to add these 3 together. I'm adding them. And for an answer, I got 58.43. So right here is 58.43. Okay, so now I'm ready to calculate standard deviation. Standard deviation is the square root of the sum that you just added up in column D divided by the number of trials minus 1. So don't worry about it, but the number for this experiment, you did 3 trials, minus 1 is 2. So that's why this number here is a 2. That looks messy, and I'm going to make it go away. Okay, so let's see. I'm going to scooch maybe my paper this way if it'll let me. Let me do it a little bit. So let's try calculating the standard deviation here. So for that, standard deviation, maybe I'll switch colors one more time. Let's do green. S is the square root of D over 2 for our experiment. So we said that D was, trying to look at my notes to make sure I write it down correctly. D was 58.43. And then it's over 2, and we take the square root of all of that. And so for an answer, I get the standard deviation was 5.41. So I'm going to write 5.41. Now to get the standard error of the mean, SE sub x. Everybody likes to joke that it looks like sex. SE sub x is the standard deviation, so S, what we just calculated, over the actual number of, oh, I'm supposed to correct that. That should have, on your table, I think it says 3 there, and that is correct. It is 3 because you did 3 trials, so N is the number of trials. So I can go ahead and, let's see, I think I can, there we go, and turn that into a 3 now. So S was from here, and so SE sub x is 5.41 divided by the square root of 3. Now, order of operations is a little bit confusing in that circumstance, but you need to figure out the square root of 3 first. And the square root of 3 is 1.73. So you're going to do 5.41 divided by 1.73. And so our SE sub x in my example is 3.07. So we're going to write 3.07 right there. Okay, it feels like we're done, only we're not anywhere near done. Earlier on in the lab, you had to make a graph. So I'm going to switch one more page. So the last page of the lab says, now add, I'll make it bigger so you can read it a little bit better. Now add 95% confidence intervals or error bars to the graph that you had on, which is figure 1 on page 2. And the error bars are going to be plus or minus 2 SE sub x. So we calculated just now that we said SE sub x was 3.07. Well, your error bars are going to be plus or minus 2 SE sub x. So it'll be, I have it written down somewhere, 6.1, oh good, I can do that in my head, plus or minus 6.14. Well, what are we even talking about, KJ? I have no idea what that means. So let's pretend that this is your graph, and I don't know how to do it, so I'm just going to kind of make it up here. Let's say on your graph you counted by 5. So let's say you went 5, 10, 15, 20. Hopefully this will work on my size graph. 25, 30, 35, whatever. Okay, your first trial, we said the mean. I'm forgetting all of a sudden. Hold on, give me just a second. The first trial was, it was 24.73. That was the mean. So you graphed 24.73. Let's switch colors here one more time. So let's try purple. So you would have graphed like this, 24.73, so close to that 25. So that's what your graph should have looked like when you started. Now you're going to add what are called error bars that show our confidence interval, the 95% confidence interval. And so your error bars are going to go above by 6.14 and below by 6.14. So if this right here, if this is, oops, I meant to write a 2 and I came out with a 3. If this is 24.73, that's what it was for me. If you added 6.14, you would get 30.87. So I'm going to draw a line at 30.87 roughly. And then if we subtracted 6.14, we're going to get another line at 18. I can't read my writing. Is it like 67, 18.6? I can't read my handwriting. Sorry. We'll say 18.67. Okay, so it's going to be somewhere about here. These are our error bars. And so you draw it like this. You draw a line straight through like this. And what is this saying, KJ? What is the significance of this? Well, this tells us that if we did this experiment, let's say we did it virtually an infinite number of times. We did this experiment over and over and over and over and over and over again. The true mean, the true answer, this true answer is going to be with 95% confidence somewhere between here and here. We know if we did it, we only did it 3 trials. We only did 3 trials. I'm going to talk to you face to face. We only did 3 trials. So if we did like 10 trials, can you imagine that maybe the mean would be a little bit higher or a little bit lower, depending on how, maybe the person got faster or something like that. If the trials changed a little bit, we could imagine the mean changing a little bit. So what we're saying is after 3 trials, we have 95% confidence that the mean would fall somewhere between 30.87 and 18.67. Well, those are pretty huge error bars when we have what we're talking about here. So I just want to give you a really quick example about how statistics really work. If we did this experiment 500 times instead of 300 times, let's go back to our calculation of SE sub x. Let's see if I can move my screen. Let's go back to that calculation of SE sub x. Do you remember that calculation was for mine, it was 5.14. That was the standard deviation. That was S over, and it was the square root of N, which was the number of trials. Now, for us, the number of trials was 3. So that's a really small number. But let's say that instead of 3, let's say that we did 500 trials. You do the square root first. So the square root of 500 is, I wrote it down so I wouldn't have to calculate it. It's just 0.24. Did I do that right? Nope, I didn't do that right. Hold on. Sorry. I wrote it down wrong. The square root of 500, duh, look at it and be like, no, that's not right, KJ. The square root of 500 is 22.4. There we go. So it's actually a pretty big number. And when you do 5.41 divided by 22.4, you get a really small number. So SE sub x is just, in that case, 0.24. Look at what a tiny number it is compared to the 6.1. Oh, sorry, I got to multiply it by 2. So times 2 because it's plus or minus 2 SE sub x. So 2 SE sub x would have been 0.48. So compare this tiny number, 0.48, to the 6.14. So now if I had that exact same graph, and here's my 24, that's my original. If we had done this experiment instead of just 3 times, if we'd done it 500 times, our error bars would be like here and here. And we would have so much confidence that our mean was spot on. We'd have 95% confidence that it's going to fall in this tiny, tiny range. Now, the last thing that you need to do, and this is the trickiest part, it's not the trickiest part, it's just a tricky part. Let's say we have 3 graphs that look like, I don't know, look like this. Those are my 3 graphs, 3 bars. And let's say you've put in your error bars. And let's say your error bars, I'm going to try to draw them off the top of my head and see if I can make this make sense. Let's say it looks like this. And it looks like this. Let's see, those are our error bars. Okay, so now what you're looking for is any mean, any bar whose error bars don't overlap. So I want you to see that this error bar is overlapping with this error bar. So these are not significantly different. The means fall somewhere in those error bars, and we can't say there's a significant difference. But this error bar doesn't fall in either one of them, theoretically, if I drew it correctly, which I didn't. Let's pretend it doesn't fall in any of them. Maybe this one is significant. Hey, we've got a significant difference between this error bar, between this bar, this mean, and these ones. It's significantly different. So that's what we're looking for is, are we finding any significant data? And you may or may not, depending on what's going on, you may or may not find significant data. We'll take a look at that data once you're done with the lab, and then we'll talk about what the meaning is of your data. Boy, I hope that helped. Yeah, see me if you have any questions or email me or whatever. We'll get this worked out. Okay, goodbye.